All right there, friends. Today we're going to look at dividing radicals. So we're taking it to the next level. Dividing radicals is a little more challenging simply because the process is a little lengthier. So just bear with me here. At the very least, write the steps down. When we want to divide radicals, we can only do that if they have the same index. Remember again, the index is the value that, or the root value. Right here you see that there are two different ways we can write it. We can write it as two separate radicals or one giant one. They mean the exact same thing. Essentially just separating it into a numerator and denominator. All right, so here are our steps. So we're going to list all the prime factors, just like we do when we're simplifying. We're going to eliminate, if I could spell, that would be fabulous. What we're going to call the ones. What I want to talk about is when you have a fraction that's like 2 over 2, that equals 1. Just like if you have a over a, that has a value of 1. So those are the ones that we're looking at. So we're going to be eliminating any values that are that are the same in the numerator and denominator. Okay. We're going to circle groups. We're going to take those roots. And then we simplify. And we're also going to eventually do something called rationalizing. We're not going to do that. Well, we'll call it, let's see, let me fix that. We're just going to call it rationalize. We'll talk about that on day 2. So today is more about just to simplify. So here's our first pair of examples. We're going to stretch this out into those prime factors. So when we do that, we're able to circle our groups. There is nothing to cancel in the numerator and denominator, so everything gets circled. So what we were able to do is eliminate those radicals. So then in the numerator, we have a 3. And then in the denominator, we have 4 because this would be 2 times 2. So this would be simplified. Okay. All right, let's move on to the next one here. I'm going to stretch these two out. So here for the numerator, I have 5 times 5. And the denominator, this is going to be a little bit longer. This is going to be 5 times 5 times 5 times 5, okay? So in this case, what we are going to do is cancel ones. So if you notice, there are 5s in the numerator and denominator, so I'm going to cancel those. I'm going to cancel a pair here, so then I'm left with only a pair of 5s in the denominator. So what that leaves me with is a 1 in the numerator and a 5 in the denominator. This gets me exactly what I need. Our radicals disappear because we either canceled or circled, and we're left with 1/5. All right, let's try this one here. So I'm going to stretch everything out and then go from there. So for the numerator, we have 10 times the square root of 3. You can't do much with that. And the denominator, I'm going to have 2 times 2, 2 to the 6th power. I am not able to cancel anything out. I don't have any 1s. So then my next step is going to be to circle. So I'm going to circle any pairs that I can because my index is a 2. So then in the numerator, I'm left with 10 times the square root of 3. And the denominator, I'm left with 2 times 2 times 2, which is 8. Now, of course, I have a fraction here that can be simplified by 2. So when I do that, I end up with 5 times the square root of 3 over 4. This is as simplified as we can get it. All right, let's try another one. For 81, this will be 3 times 3 times 3 times 3. In my denominator here, I have 7 times 7 times a. Lots of a's there. So in this case, I'm not able to cancel, so I'm going to circle where I can my pairs because my index is 2. If you notice, I was able to circle everything. So that means my radicals are gone. Which leaves me with, in my numerator, I have 3 times 3, and the denominator 7 times a times a times a. So that leaves me with 9 over 7a cubed. All right, here's our next pair. So I'm going to start with the numerator. I'm going to stretch this one out, which isn't much because it's just going to be 5 and the square root of 2. In my denominator, I have 10, and then 225 is pretty lengthy here. So this would be 3 times 3 times 5 times 5. Now, once again, I cannot cancel anything in my numerator and denominator except maybe that fraction on the outside there. I can divide as if it were a fraction, so this would become a 1 and this would become a 2. The next thing I can do is my grouping. So then in the numerator, I'm left with the square root of 2 times 1, which doesn't change anything. And then in the denominator, I have 2 times 3 times 5. So really, I have the square root of 2 over 30. Okay? All right, let's move along. So I'm going to go ahead and stretch this one out. So I have 3 times the square root of 2. Then in the denominator, I have 12 times, and when I break down 72, that's 2 times 2 times 2 times 3 times 3. Now, I do have some simplifying that I can do. So I have the fraction on the outside. I can divide by 3, so this becomes a 1, this becomes a 4. I have a pair of 2's. I have 2's here and a 2 here that I can cancel. Now I'm left with groups. So I'm going to do my grouping. Notice everything was either, well, almost everything was either canceled or grouped under those radicals. So the radicals are gone again. So in my numerator, I'm left with 1. Let me actually rewrite that. I'm left with the 1 in the numerator, and in the denominator, I have 4 times 2 times 3. So then I'm left with 1 over 24. This is one of my favorite things to do.